Hi everyone, today we are working on lesson 3, lines of best fit. So we are drawing in lines of best fit on a scatter plot. Remember that when you draw a line in, you want about the same amount of data points above the line as below the line. And we're also going to be using those lines of best fit to analyze the data and make sense of it. Lesson 3, lines of best fit. Your learning target for today is I can sketch a line of best fit given a scatter plot and use the line of best fit to analyze the data. So if you're working on a Google Doc today, that means that drawing in your line of best fit is going to be tricky. But if you're watching the video, you can have me do it for you, and then you can answer your questions based on my line of best fit. So today we're really just working with one word problem today and drawing in a line of best fit and making sense of it. So let's take a look at number 1. Boxes are being loaded with apples. All of the boxes are the same size, but have differing numbers of apples in them. Each box is weighed, and the weight is compared to the number of apples in the box. The results are shown in the scatter plot below. So looking at the scatter plot to the right here, now I see on my x-axis, I've got the number of apples. On my y-axis, I have the weight. Now let's just think about this. Apples, think of one apple. You pick an apple from a tree. Are they going to be the exact same weight? Probably not. Are they going to be really close? Probably. So there's not a perfect answer to this. We want to draw a line of best fit through the data and extend it so that it intersects with the y-axis. Again, you might just have to watch me do this. Okay, so that's approximately the line of best fit. So it says, is this a positive or negative association between the number of apples and their weight? So as I read from left to right, is it going up or down a hill? It is going up. So this is a positive association. Again, remember, just think about it. As the number of apples are increasing, the weight is going to increase. So that's why it's positive. Then it says to estimate the y-intercept of your line of best fit to the nearest half pound. So my y-intercept is where my y-axis intersects my line intersects the y-axis. Okay, if you see, it's between 2 and 4, so that's about around 3. Now it says to the nearest half pound, so we don't really need to do the half pound here. Okay, so we're just gonna say 3 pounds, approximately. How can you interpret your answer from C in the context of this problem? So let's think about this point right here. This is my y-intercept. That coordinate is really 0, 3. So we want to interpret what those numbers mean in the context of the problem. So remember, first comes our x value. Our x value is at 0. So my x-axis is the number of apples. So that means I have 0 apples. Okay, the y value is at 3, and 3 is the y-axis for the weight of the box plus the apples. So if there's no apples, how can we have a weight of 3 pounds? Well, it's the weight of the box without any apples. So the box weighs about 3 pounds without any apples. Okay, and that's all we got for today. So you can self-assess for today's lesson. If you have any questions, please let me know.